This is question number 46 of GATE 2018 Metallurgical Engineering. A single crystal of aluminum is subjected to 10 megapascal tensile stress along the 3 to 1 direction. The resolved shear stress on 111 bar 101 slip system is in megapascal. So to know more about the resolved shear stress, you can refer lecture on the topic resolved shear stress from the course Introduction to Materials Science and Engineering by Professor Rajesh Prasad from IIT Delhi. So let's first understand some basic concept behind this problem. So now let's say this is a single crystal, and in that crystal we are applying a tensile stress, let's say that is sigma, and which is acting basically in 3 to 1 direction, right? So we are applying stress in this direction, 3 to 1 direction, and the slip plane in this crystal is, let's say, oriented like this, and the slip plane is having the Miller indices 111 bar, and in this slip plane the slip direction is in 101 direction. So combining these two will be telling us the slip system. So this is our slip plane, and this direction is nothing but our slip direction, but the load is acting in this direction. So the slip will occur only if this load, applied load, when this load is resolved on this plane in this direction, exceeds the some critical value, right? And the angle which we should learn here is, like, there are basically two types of angle forming here. The angle phi is nothing but the angle between the applied tensile stress and the plane normal direction, right? So this is our slip plane, and the normal to this plane will dictate the direction of this plane. So the angle between plane normal and the applied stress will be phi, and the angle between the slip direction and the applied tensile stress is lambda, right? So this is phi and this is lambda. Now before solving this, let's first understand how do we calculate the angle between two directions, or like angle between plane normal and given directions. So let's say there are two directions, u1 v1 w1 and u2 v2 and w2. So if you want to calculate the angle between these two directions, so the cos theta is given by the dot product of these two, that is u1 dot u2 plus v1 dot v2 plus w1 dot w2 upon under root of u1 square plus v1 square plus w1 square into under root of u2 square plus v2 square plus w2 square. So this is how the angle between two directions are calculated. So in our case, first we will calculate the value of cos phi and cos lambda. So the cos phi will be between the plane normal and the applied stress direction. So for a given plane, let's say this is 111 bar, the plane normal direction will be nothing but the direction 111 bar only. So the indices of plane will be same as the indices of plane normal. So we have to calculate the angle between 111 bar and the applied stress direction, that is 3 to 1. So for calculating the angle between these two, that is cos phi, what we'll do, we'll make a dot product. So 1.3 will give us 3 plus 1.2 will give us 2 plus 1 bar dot 1 will give us minus 1 upon under root of 1 square plus 1 square plus minus 1 square, which will give us under root 3, and under root of 3 square plus 2 square plus 1 square, which will give us 14, right? So if you solve this, this will give us 4 upon under root of 42. So we got the value of cos phi. Similarly, we will calculate the value of cos of lambda. So the cos of lambda is nothing but, so it will be between 1 0 1 direction and the applied stress 3 to 1 direction. So for them, the cos lambda will be 1.3 will give us 3 plus 0.2 will give us 0 plus 1.1 will give us 1 upon under root of 1 square plus 0 square plus 1 square will give us under root 2 dot under root 3 square plus 2 square plus 1 square will give us under root 14. So it is 4 upon under root of 28, right? So we got the value of cos phi and cos lambda, right? Now what is our resolved shear stress? So resolved shear stress, resolved shear stress, if you denote it by tau RSS, it is basically sigma, which is applied stress, times cos phi and cos lambda, right? So this cos phi and cos lambda is sometimes referred as a Schmidt factor, right? So cos phi into cos lambda, we call it as a Schmidt factor, multiplied by the applied stress will give you resolved shear stress. Now we will put the value of sigma, cos phi and cos lambda. So sigma is given as 10 megapascal times cos phi 4 upon under root 42 into 4 upon under root 28. So if we solve this, we will get the value of resolved shear stress equals to 4.67 megapascal. So the value of resolved shear stress is 4.67 megapascal. So this will be the right answer. Thank you.